Okay guys, so what we have right now, what we're going to be doing is learning how to solve, alright, for different variables in a series circuit. So before we jump into that, just want to go over a couple little what the symbols mean. Alright, this little guy here, line, is a wire through which the current is going to move. This little squiggle line is a resistor, which gives you the value of the resistor. This symbol here is the battery. Now whatever the battery is, that is the total voltage of the entire thing. This guy here, if you have a little circle like that, and you can have a number in it, like let's just say 5 amps, or 5 capital A, that is going to tell you what the current is. Now remember that the current in a series circuit is the same everywhere. So if you know that reading, okay, it's the same everywhere. And then you have a voltmeter. Okay, you may see these in some problems. This is going to tell you what the voltage drop is. Okay, so starting off, we have Ohm's law, V equals I times R. And we have this example problem here with our series circuit. We have a battery of 12 volts, a resistor 1, 50, resistor 2 of 100 ohms, and resistor 3 of also 100 ohms. Now, it's very important that you make sure that you know everybody goes together. So the total voltage, VT, goes with the total current, IT, and the total resistance, all right, RT. V1, the voltage drop across resistor 1, is going to go with R1 and the current through that, I1. And just kind of keeps going. V2 is going to go with I2 and R2. So how are we going to go about this? So I'm going to start it off like this. Make yourself a little table, alright? However many rows correspond to however many resistors you have. If you only have 2 resistors, you're only going to do 1, 2, and T for the total. Right now we have 3. So once you draw this out, the first thing you want to do is write in your given information. We were given 50 ohms as R1, right? So R1, R2 was 100, and R3 was also 100. You are then given the total voltage, all right, the battery. That goes down here for VT. All right. Now technically the rest of this would be blank right now, but this is already worked out. I'm just going through how to do this. So the next thing you want to do is find the total resistance. Alright, so by finding the RT, you add all of them up, because in a series circuit, RT is equal to I1 plus R1 plus however many resistors you have. This comes out to be 250 ohms. Okay, so if these guys were blank, you need 2 out of these 3 in order to use Ohm's law to solve for the missing. Alright, as of right now, the total is the only one that has 2 known values, 12 volts, 250 ohms. So we're going to make sure, as it going forward, all the T's go together, the totals. Total current is going to equal total voltage over total resistance. So we're going to throw it 12 volts over 250 ohms. Dividing out, and you get 0.048 amps. Okay, so we're going to put that in here down for IT. Now, again, series circuit, once you know what the current is at one point, it's the same at all points. So now we have all of this. Oh, sorry. So the only thing we don't have then would be the V1, V2, and V3. So then, going into Ohm's law, right? If you have 2 out of the 3, you can solve for the missing. V is equal to I times R. If you cover up V in the triangle, they're next to each other, you multiply. If you knew what the resistance, or you were looking for resistance, but you knew what the voltage and current were, it would be V over I to get R. Okay, so set it up. V1 is I1 times R1, and we're just going to substitute in 0.048 and 50. Multiply out, you get 2.4. V2 is I2 and R2, 0.048 times 100, you get 4.8, and V3 is I3 times R3, 0.048 times 100, also 4.8. What you need to do from there is you need to make sure that the sum of the voltage drops, V1 plus V2 plus V3, is going to wind up equaling out your VT, your total voltage. Okay, can't be any more, can't be any less. Okay, it's got to be that exactly. This problem works out nice and neat. Okay, add them all up, it does equal to 12. Once you have it equal, then I would write these values in. All right, your 2.4, your 4.8, and 4.8. Okay, and that's how to do this basic, simple series circuit problem.